Done. Okay, number 65. Let's read through it real quick. A bicyclist is finishing his repair of a flat tire when a friend rides by with a constant speed of 3.5 meters per second. Since the first person they gave us information about is the guy who went by at 3.5 meters per second, I'm going to call him Object 1. Okay? If you call him Object 2, that's fine as long as you were consistent throughout your problem. 2 seconds later, the bicyclist hops on his bike and accelerates at 2.4 meters per second. All right, we're going to call that 2 seconds later, the time when the bicyclist hops on his bike, we're going to call that the 0 point. And that is why I have him back here at x equals 0, but this guy is out here beyond x equals 0 because he's moved forward for 2 seconds. Okay, where the heck was I? So he hops on his bike and accelerates at 2.4 meters per second squared until he catches his friend. Part A, how much time does it take until he catches his friend? So we are trying to figure out what this final time is, which we're just going to call t. And at that position, they're both at the same place. So the x final is the x1 final, which is equal to the x2 final. Okay, so they're both in the same position at that point. Part B, how far has he traveled in this time? The he that they are referring to is the two bicyclists, the guy who jumped on his bicycle and was behind the other guy. Guy 2, I don't have to say x2 final because that final position was the same for both. And how, I just about read the question above it. How far did the chicken slide? No, wrong question. What is his speed when he catches up? Okay, so that's V2 final. All right, before we go any place, this is a variable we don't know about, but it's a very simple variable to figure out. And since he is not accelerating, his position is going to be equal to his velocity, which does not change, so I'm not putting an initial or a final on it, multiplied by how long he pedaled until he got here. How long did he pedal to get here? 2 seconds. So I'm just going to say multiplied by 2.0 seconds. So that's 3.5 meters per second times 2 seconds. So that's 7.0 meters. That's going to make our life easier for the rest of the problem. Okay, now we're going to start with this guy over here. Okay, the fact that the positions are the same. So we're going to write a statement for his final, bicycle 1's final position, and a statement for bicycle 2's final position, which is very much like we did yesterday. Bicycle 1's final position is equal to bicycle 1's initial position plus his bicycle 1's initial velocity multiplied by the time through which he rides, plus any acceleration that he experiences. We know that's 0, multiplied by the time getting squared. Now we can start crossing off some things. That is not 0, we need to keep it. That is not 0, we need to keep it. This is 0 because he is not accelerating, so that part goes away. Bicycle 2, the guy who hops on his bike, the general expression is V2 initial plus V2 initial times time plus 1/2 the acceleration of bicycle 2 multiplied by the time duration that we're dealing with squared. This guy here is 0 because he started from the 0 point. This guy here is 0 because he wasn't moving. So now we have this equals this. X1 initial plus V1 initial times time equals 1/2 the acceleration of bicycle 2 times time squared. Rearrange this so it looks like something we can put into a quadratic equation. 0 is equal to 1/2 acceleration 2 times the time squared minus, because I got to bring it to the other side, V1 initial times time minus, because it also came to the other side, x1 initial. Let's get some numbers in here so that we can figure out what A was, B was, and C was. A is going to be 1/2 times the acceleration of bicycle 2. He is accelerating at 2.4, so that's going to be 1.2. I'm not going to show that. I am going to put units on it, though. Meters per second squared multiplied by t squared minus V1 initial. V1 initial was his constant velocity of 3.5. 3.5 meters per second. Minus x1 initial, which we determined a little earlier, was 7.0 meters. Okay, so as far as the quadratic equation goes, where t, because that's our variable, is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I'm going to move this up at this point. All right. B was negative 3.5, and I am still going to leave some units on this thing. Meters per second plus or minus the square root of b squared, which is negative 3.5 meters per second getting squared, minus 4 times a, which was 1.2 meters per second squared, times c, which is a negative 7.0 meters. All of that divided by 2 times a, which had a value of positive 1.2 meters per second squared. Remember, a is not an acceleration. A is the term in front of the squared variable for figuring out the quadratic equation. I hate the fact that the a term has the acceleration terms inside of it. Okay, that always confuses everybody. Now it's calculator time. And so, let's see, t, all right, 3.5 squared. I'm not going to bother with the negative because I know it's going to go away. Minus, open parentheses, 4 times 1.2 times 7 negative, close parentheses, equals, this is the stuff that's inside of my square root symbol. Then I square root that. Okay, I better write that down at this point because I know I'm going to lose track of it. 6.77. That is one more significant digit than I need, which is good. Let's look at the units for a second. Meters over seconds squared. That's meters squared over seconds squared. Minus, that's got no units. This has meters per second squared multiplied by meters, so that's meters squared over second squared. Okay, so we're adding meters squared over second squared together. It's getting square rooted, so it's meters per second, which is good because it's got to be added or subtracted from meters per second. Okay. And the only other thing I would probably do is write down 2.4 meters per second squared down here. Now I'm going to figure out my two values. All right, 3.5 negative. 3.5 negative, let's do the plus first, plus 6.77 is 3.27 divided by 2.4 gives us 1.36. I am not allowed to have, I'm only allowed to have two significant digits, so I'm going to say that's 1.4. 1.4 seconds is one possibility. The other one with a subtraction, 3.5 negative minus 6.77 is negative 10.27 divided by 2.4, negative 4.3. Am I allowed to have that one? No, I am not, because time is not allowed to be negative. And if I looked back here, top of this was meters per second, bottom of it is meters per second squared. Meters cancel, one set of seconds cancel. I've got 1 over seconds. That's the same thing as seconds. So we've got our part A, our part B for the final position, I'm going to go back up here to this guy. And so x2 final is equal to 1/2 the acceleration of the second bike, which was 2.4 meters per second squared. Our time we just figured out is 1.4 seconds. I'm going to square that. Let's see, 1.4 squared times 2.4 times 0.5. I have a tendency to work backwards. I did have dyslexia. I still have dyslexia. It's just I don't notice it too much. That's 2.4 meters. And it was positive. No way of it becoming negative. And our V2 final... well, what do we do for V2 final? Easiest kinematic equation we have. Easiest kinematic equation we have is VVAT, but we're going to be talking about the second guy. So V2 final equals V1 final. That's super easy. I'm sorry, V2 initial. That's super easy because that was 0. Plus the acceleration. This is a bicycle 2 multiplied by the time. So in other words, my final velocity is my acceleration times the time. So that was an acceleration of 2.4 meters per second squared. Very coincidental that we're getting the same thing in here again, multiplied by our time of 1.4 seconds, giving us a final velocity of 3.36 or 3.4 meters per second for our final velocity, and they're all positive, and we're done and we survived. Yay!